Welcome to the part 6 in this video series about Echinoidea, a temporary pavilion built in Milan in Italy 2022. Today we are going to move the geometry from Rhino and Grasshopper to BIM objects in Revit. And as you see, I already started my Revit and I will create a new file. And I will use metric architectural template, press OK and start my project. It takes some time to start Revit. As you see, I already have Rhino inside Revit installed in Revit. That's plugin. Rhino inside Revit is plugin for Revit. You open Rhino inside Revit from Revit and that's the only way you can work with Rhino inside Revit. Let's go to the plugin. I'm not going to explain how to install Rhino inside Revit. There is plenty of information about installing Rhino inside Revit on internet. If you don't have Rhino inside Revit installed already, go and download it. I think you download it from McNeil's website and then you will find the information how to install the plugin. Let's go to the plugin. First press this start button and as you see I have orange dot here and it means that there is a new release of Rhino inside Revit. I will update that later. Just press the button to start the plugin. It takes some time to activate the plugin, for me anyway. First I open Rhino by clicking this button and now Rhino is open, and you can open Grasshopper either by clicking this button in Revit or on this Grasshopper button in Rhino. I will open my Grasshopper from Rhino. As you see, before I open my file, maybe you already know this, when you start with Revit and open Rhino from Revit and then Grasshopper from Rhino or from Revit, it doesn't matter, you have tools that you otherwise don't have when you open Grasshopper and Rhino only. That's those tools in Params menu, and then you have even this Revit. And don't panic if you open Rhino and Grasshopper without using Revit. You are not going to see those tools. So just that you know, you see them only when you start the programs from Revit. Now I will open my file, my Grasshopper file. And I already did this before and we start together from the scratch. I'm going to continue working in the same file. If you want, you can bake the geometry from Grasshopper to Rhino. Here is our geometry. As I said, I'm going to continue working in my original Grasshopper file. If you want, you can bake the geometry that you are going to work with in Rhino and save it, and then open a new Grasshopper file and import the geometry and start from the scratch, so to speak. But I'm not going to do that. I will continue working in the same file. The only thing I'm going to do, I will take Scribble, and here's my Scribble. I will write here Rhino inside Revit. I will not use camel case. And then I will have the text size 100 so that the text is well visible on the canvas, and I will work on this side of the screen. And I'm going to take empty prep components. I will store my sticks here, call this one R1, okay, and via display hidden. And I do the same thing with other two rows. I call this one R2 and via display hidden. And let's do the same thing for the last row. Change the name to R2 and via display hidden. I take those three reps, I group them together. It's easier to move a group from one side of the screen to another side of the screen. That's why I'm grouping them. Now I move them and now I can ungroup them. In this tutorial we will work only with the row 1. In order to use Rhino inside Revit, you have to have good knowledge about Revit families and good knowledge about Grasshopper. And as you see, using Rhino inside Revit plugin means that all three windows, Revit, Rhino and Grasshopper, are open at the same time. You have to move those windows. If I want to work with Revit, I have to move those windows to see as much of Revit screen as possible, and then to activate Revit you click on the upper side of Revit window. And the same thing with Rhino. If you want to activate Rhino window, just press this upper side, and the same with Grasshopper, you have to click on this upper side of the Grasshopper window. As I said, we will work with this bottom row to start with the row 1, and the first thing we need to do is to analyze the information in Grasshopper before we start moving the geometry from Grasshopper to parametric families in Revit. As you know, everything you draw in Revit belongs to a parametric family, and that's what we will do. We will use Revit families in order to move geometry from Grasshopper to BIM objects in Revit. As I said, first we need to analyze the information. To do that, let's bring the panel and see what we have here. Let's see, we have individual breps, 39 components, 38 plus 1 because Grasshopper starts with 0. We have 39 breps. All the breps are stored in this component as individual objects. Now I'm going to flatten them to make one group of all of those breps, to put all the breps in one group. Let's go to surface and take deconstruct brep. And let's connect faces to this yellow panel, and now you see we have the information about how many faces each brep has, and we even have the information about each face. For instance, this first brep with this index value 0 consists of 6 untrimmed faces or surfaces, and the next brep with the index 1 consists of 10 faces or 10 surfaces, and the first surface with this index value 0 is untrimmed surface. The next surface is trimmed surface, or actually the next 3 surfaces are trimmed surfaces, and then we have 2 untrimmed surfaces and then 4 trimmed surfaces. The next brep has also 10 faces and the same pattern of untrimmed and trimmed surfaces. And what we are going to do, we are going to group these breps according to the number of faces and according to the pattern. Breps with the same number of faces and the same pattern of untrimmed and trimmed surfaces are going to be in one group. I already analyzed this information, and I think breps within this number from 0 to 35, I think, have the same pattern and the same number of faces. Let's see. Yeah, exactly. Breps with the index number from 0 to 35 have the same number of faces and the same pattern of untrimmed and trimmed surfaces. That's why I'm going to put them in one group. Then I have brep with the index number 36. That brep has 11 faces and this pattern untrimmed, trimmed, 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 untrimmed, untrimmed, and then 5 trimmed surfaces. And the next brep within this number 37 has the same number of faces and the same pattern. That's why I'm going to put them in one group. Then we have a brep with the index number 38 and it has 10 faces and this pattern. And then we have the brep with the index number 39 and it has 9 faces and this pattern. Let's start with grouping the breps according to the number of faces and surface pattern. So this one has only 6 faces and it's going to have its own group. I will take a list item, connect this list to this item, and this is my first brep, the one that has only 6 faces. That's this one. Then I take the next group. The next group are all the breps with the index number 1 to 35, I think. For that I'm going to use, let's see, cal index and connect these breps from this flattened group, and then I'm going to exclude the breps with the index value 36, 37. Let's start writing, otherwise I'm going to forget. I use panel and write my indices here: 36, 37, 38, 39, and even in this 0. Okay, connect to this indices list, right click and press multi-line data, and now it works. In this group I have all the breps except for those values. And this one is 0. For the next group, breps with index number 36 and 37, I use list item, connect this flattened group. Let's take the yellow panel again, and here I will write 37 and 38. Multi-line data to get the list. Now I have these two breps in this group. I think I will turn off the original breps and even this deconstruct brep component. And now I have these two breps, and I do the same thing for the last brep. The last brep is the brep with the index number 39 that has 9 faces and this pattern. Let's take a new list item component, connect it to this flattened group, and here I will have index number 39. Since I have only one value here, I don't need to turn off multi-line data. And now here's my last brep, and here I will write 0. We don't need to do that because default value in the list item is 0, but I will write it anyway and connect. I will turn off these original sticks, I don't need them anymore. I do not need this panel, I will erase it. I don't need deconstruct brep component anymore, I just use it to analyze the sticks. And now I see one component is missing, and let's see. This one is missing. 39, 38, 37, 36. Yes, I don't have 36. I excluded 36 from this group, and in this group I only have 37 and 38. In this group I have 39. I will bring the yellow panel again. Let's see. Actually, 36 and 37 have the same pattern and the same number of faces. Then we have 38 and 39, they are own groups. And let's see, here I will write 36 and 37. Then I will have one list item with the index value 38. Press OK. Let's turn this deconstruct brep component. Now I have all my sticks. Now we did this first part. We analyzed the information in Grasshopper, separated the sticks according to the number of faces and according to the pattern of trimmed untrimmed surfaces. Now we will start with this first stick. That's the simplest one. It only has 6 faces and it doesn't have any joint. And what we are going to do, we are going to make a Revit family without joints. And I already tested this many times. We could move the information from Grasshopper to Revit using adaptive points or even using generic models. The best way to move those sticks from Grasshopper to Revit is by using column family. And let's go to Revit, activate the window, new family, English, and metric column, open. And as you know, our sticks are 100 by 100 millimeters. That's why we are going to change width to 100 and depth to 100 as well. And now we go to create extrusion. Let's take this tool, extrusion, and let's go to front view. We need to press this green button, green check symbol, and let's go to the front view here. And by default the extrusion is 250, but we will connect the extrusion value to a parameter. We will define a parameter for this extrusion value, a parameter that we are going to call cutting length. And that's the only parameter we have in this family. Actually, I will save this and call it stick 1. File, save as family columns stick 1. Save. Choose this stick again. Press here to define a new parameter. We will choose shared parameters because we are going to use the same parameter for all groups. We will use it on instance level. Select. Now we will create a text file where our parameters are going to be stored. Press create, and I'm in my family map and I will call it Echinoidea. Here I'm going to have all my parameters, shared parameters for this project. Save. Choose new group and let's call it dimensions. Okay, and create a new parameter. And this one I'm going to call cutting length. And discipline common and type of parameter is length. Okay, press OK again and again. Okay, now I have my parameter cutting length. Press OK. It's a little bit too short, but it doesn't matter here. We can make it a little bit higher. This parameter we are going to read in Grasshopper and import this parameter in our project file. Now I have that family. I will load this family into my project. Load into project, and I will I press here. Now I have my column. I will erase this, and now I have my column in my families. And let's see, columns, and my stick 1 is here. This is my project. I will save the project as well. Save as project. Let's call it Echinoidea BIM. Save. Let's go back to Grasshopper and Rhino. This is my stick. And now I need the information about the cutting length. The cutting length is equal to the lines that we generated before we generated the sticks. And I need to find that line. That line is, I think, this is my row 1 and here are my lines. Let's read them. Connect them to an empty curve component. Here are my lines. I have to exclude every second one according to this pattern that we used before. I copy the pattern, take cal pattern, connect the list to the list item and pattern to cal pattern component, and nothing happens. We need to flatten the list. And now I have only every second line. I only have the lines that we used to generate the sticks. Move. I will group it first. It's easier to move a group than components separately. And put it here to start with. Move everything else. Actually, these are my lines that I need for the first row, so I will put them together with the sticks. And now I need the length of this first line. Let's go to set, list item, and let's connect the list to the list. And yes, and now you see this line doesn't have the same index as this breadth. Let's see, this line is actually the last item in this group of lines. I could just use a panel and write 39 and connect it to this index value, and now I have my line. And I will read the information from this line in order to move the information about the cutting length from Grasshopper to Revit. And let's see, now we go to this Revit menu. As you know, we used column family to move the first stick from Grasshopper to Revit, the BIM object in Revit. Let's see, this column component wants location, and our location is going to be this line. And then this component wants type, family type, and we created this family, columns, stick 1. Let's see what we have in Revit. Here we have one column. Let's go to 3D view, and now you see our stick. The stick is following this line that we used to create the stick, and it is as long as it is in the family. It doesn't have the right information about the length, and that's what we are going to do to move the information about the length to Revit. Let's see the length now. The length is 868.1 millimeters, and if we go to the family, you see that's the same length. We don't want that. We want the same length as this line. And let's see, we go to element parameter, and now this component wants the element, and the element is the output value of this column component, and let's connect it. Then this component wants the name of the parameter, and that's cutting length. The name of the parameter is cutting length, so we write the name of the parameter in this yellow panel. And we also need the value, and the value is the length of this curve. Let's go to curves, analysis, length. Let's see the length of the curve. The length of this curve is 1677.5. Connect this length value input parameter in this component, and let's go to the 3D view and see. The length of this stick in Revit file has the same value as this value in Grasshopper. That's how we are going to move the parameters from Grasshopper to Revit, using this add column component and this element properties component. This was the easiest stick without joints, with only one parameter, and I think I will stop here. This tutorial is already too long. I think it's more than 20 minutes long, and I don't like long tutorials. Before we finish, let's just remind ourselves what we have done and what we want to achieve. We generated the geometry with help of parametric design in Grasshopper and Rhino, and now we are moving the geometry from Grasshopper and Rhino to BIM objects in Revit. And the ultimate goal is to produce the fabrication drawings that we will give to the carpenters. We moved only one stick, the easiest one, the one without joints. In the next video we will analyze the joints together and build new family types with help of column family, English metric column family. As I said, we will analyze the joints. Not all joints are the same. In this first drawing they go all the way through the stick, and for those joints we need two parameters. Except for the cutting length, we need also the position of the joint and the angle of the joint. For the joints that do not cut through the whole stick, we need the position of the joint, the angle of the joint, and we also need the length of the joint. We are going to construct the joints with the help of extrusion void. For this first type, where the joint cuts through the whole stick, and if the joint doesn't cut through the whole stick, then we are going to construct that joint with the help of sweep void, and I will explain how you will define parameters for extrusion void and how you will define parameters for sweep void. I can just mention that you cannot define parameters on extrusion void, but there is a workaround that I will explain in the next video. And as for sweep void, you define parameters in relation to the sweep path. And that's all for now. See you in the next part. Thank you for watching.